Hi everyone, this is K Vamshi from ECE section and having the rule number 04M7. Today I want to discuss about the topic like overview of terahertz antennas from the top for the TikTok concept of antennas and wave propagation subject. So coming to the introduction about the terahertz, 1 terahertz equal 10 power 12 H. So you can see the various frequency spaced along the frequencies used in electromagnetic spectrum. You can find different range of frequencies which are arranged in electromagnetic spectrum according to their frequency ranges in our earth. So you can find microwaves, infrared radiation, visible lights, ultraviolet, x-rays. So these were the few lights or radiations we can found in our daily life, which has their frequency range. They are arranged in certain order according to the frequency ranges. So in a similar way, terahertz is also a radiation which has 10 power 12 Hz frequencies. So between it can we can found it between the microwave and infrared frequencies like terahertz radiation. So terahertz, it also known as submillimeter radiation, and terahertz waves tremendously they are high frequency and known as T rays, T waves, T light, T lux, or terahertz. It consists of electromagnetic waves within the designated band of frequencies from zero point 0.3 to 30 terahertz. And wavelength of a terahertz of a radiation in the terahertz band correspondingly range from 1 mm to 0.1 mm. So the wavelength range can from 1 millimeter to 0.1 millimeter. If you take general radiation at 1 terahertz, so it has the period of 1 ps and wave number as 33 centimeter, and photon energy as 4.1 milli electronic volt, and equivalent temperature as 47.6 Kelvin. So these were the some parameters in 1 terahertz radiation. So coming to the properties of terahertz, terahertz radiation travels in a light of sight. Mean we can able to see, it can visible, and it also no non-ionizing, and like microwave radiation, terahertz radiation can penetrate wide variety of non-conducting materials. Like terahertz radiation can pass through clothing, paper, cardboard, wood, plastic, and ceramic. So these were the material it can pass through, but it has limited penetration through fog and clouds, and cannot penetrate liquid, water, or metal. Due to extreme water absorption, terahertz waves cannot penetrate into human body like microwaves can. Therefore, even if terahertz do cause any harm, it has limited to skin level. So even it can pass through a cloth or paper covered some material, but it cannot pass through fog, clouds, and water. As our body contains water, so it cannot pass through our body. It can reach up to our skin, so we may get some skin problems. So you can see the generation of terahertz radiation by two methods like photoconductive technique and nonlinear optic technique. So coming to the photoconductive antenna, high energy photons create for in to the principle of photoconductive antenna. It has in first one, like high energy photons create a charge characters, and biased electric field applied accelerate these the charge produced by photons, and accelerating charges create emit radiation. Here you can see the a picture of a beam of photon radiating charge carriers which are accelerated by biased current. And of the principle of a photoconducting antennas is the laser beam is focused on dipole gap with generating electric hole pairs, and the transient current conditioned by the applied voltage emits an electromagnetic pulse of subduration into free space. So the emitted wavelengths are much longer compared to the size of their source, and the dipole hence they diffract strongly in the form of white cone, filling out almost the whole solid angle within the antenna, like dark area marked terrace. So you can see the picture of photoconductive antenna, where it includes two dipole and some beam of photon pass through it to release the charge carrier, which are accelerated by applied EMF. So this is the setup for the generation of terahertz. Like you can see the dipole, electronic gun, and many. So types of photoconducting antennas on the basis of their design. So according to their design, they are classified into another, like aperture antennas and spiral antennas, body antenna, and dipole antennas. Coming to the aperture antenna, you can see the picture of aperture antenna. It has a silicon germanium arsenic substrate and LT germanium and arsenic external area and metal components. So the charge carrier has low life and middle one. So coming to the another technique as electro optic sampling. So the laser pulses of some tens of femtosecond will pass through the scanning delay, enabling a time resolved acquisition of electric field of terahertz pulse over a multiple shots. So the analyzer consists of retarded and Voltson beam splitter, and the photo detector acquire the modulator intensities of laser pulses depending on the phase retortion. So here you can see the scanning delay, which passes the beam in through the polarization. Uh, you can find the terahertz beam passed through crystal, which get a straight wave, and it can pass through the analyzer to get detected by some detectors. So and detection of the terahertz radiation is done by two, like photoconductive technique and non-linear optic technique. So you can see the picture of detecting terahertz radiation. So detection of terahertz radiation can be done of the carriers is same as discussed earlier. The only difference is that instead of biased field, we have the time varying electric field, and we measure the time varying current, which gives information of the frequency and amplitude of terahertz radiation. So here you can see the detection of the terahertz radiation from the time varying field to the frequency varying field. So coming to the application of terahertz radiation, like it includes in micro scale and nano scale. In micro scale, we can see the 5G cellular network, TWLAN means to terabyte wireless local area network, and TWPAN, which terabyte wireless personal area network, and secure terabyte wireless communication. And coming to the nanoscale range, health monitoring system, nuclear, biological, and chemical defenses, Internet of Nano Things, and ultra high speed of one chip communication. So thank you. Have a nice day. I think you have good brief about the terahertz radiation. Thank you.